This is the second part to lessons 5.6, solving logarithmic and exponential equations. The previous lesson, we looked at 3 examples, solving a log equation and then solving an exponential equation. Today, I will take up the 3 examples from your textbook, check your understanding. Just to review, we will be using the laws of logarithm, which is what we've been using constantly. So we'll be applying the product law, quotient law, and power law, and also the exponential rules or laws. And the other one we'll be using is the change of base formula, changing a non-base 10 log to a base 10 log to solve. So we'll be applying the laws of logs and the definition for logs. This is used very frequently. And log a of a is equal to 1. So let's go to first check your understanding question. There are 3, but there are different parts to it. Here to solve log 3, 9x plus log 3x equals 4. And we're to verify our solution. The first thing you want to do, if you look here, we can use our product law. So step 1, so use product law. Should write it here. So use product law. We're trying to find the value of x. That's our goal. By using the power law, we'll combine log 9 of x plus log 3 of x. Remember our power law? Just a quick. So our product law. So product law where we have log b of x plus log by will give us log bxy. So that will give us log of 3, 9x multiplied by x equals 4. Simplify this, this gives me log 3, 9x squared equals 4. Now, this looks very familiar now. We have a log. We are going to write it as an exponent. So next step, write as an exponent. So this is your base. This becomes your exponent. So the log is an exponent of an exponential function. So we have 3 to the power 4 is equal to 9x squared. Let's simplify this a little bit further. 3 to the power 4 is equal to 81, I think. Let's see here. So make sure I'm on the right track here. 3 to the power 4, 81. 9x squared. Divide both sides by 9 because 9 is a common factor. So you have 81. So we are left with x squared will be 9. So we have 9 is equal to x squared. Simplify, square with both sides. So x squared plus or minus. So x is plus or minus 3. Now, since we cannot have, oops, since we cannot have a negative log, like a negative number for a log, so we can put here since there is no negative number for a log, x equal negative 3 is extraneous. So it's an extraneous solution. So our answer would be x is equal to 3. So x is not equal to negative 3. The next part of the question to verify the solution. So we have x is equal to 3. So I'll rewrite my log. We have the left side. Let's put here left side. This ls is log 3, 9 plus log 3x. Now, let x be x equal to 3. So we have log 9 times 3 plus log 3x. Now, this becomes log 3 to 27. That's log 3 to the 3. Okay, now we can make, now we are using, if you look at our principle as log b to the bn is equal to n. Just to show you what is like be 3 to the power 3. Right. 27 could be written as 3 to the power 3 is equal to 27. Plus, now this is 1 there, we can rewrite this as 3 to the power 1. So using this definition for log, we have log 3 to the 27 is equal to 3. Log 3 to the 3 to the power 1 is equal to 1. So 3 plus 1 is 4. Which is equal to the right side. So this is equal to the right side. The right side is 4. Go back to our question. Our right side is 4. So our left side is 4, equal to 4. And that is verifying for a solution. So the left side is 4, which is equal to the right side. Okay, we're going to another check your understanding question. This question, you're asked to solve and verify the equation. So the first step you want to take is to find out where the values for x with each log is defined, where these are defined. So step one, consider the values of x for each for each log is defined. So where x is defined for this log and x defined for this log here. So step one, so consider the values for x, which is the value of x, I should say, value of x, for which each log is defined. So look at the first one here. So here, I'll just rewrite it here. 3 is equal to log 2x plus 2 plus log. So for the first one, we have x has to be greater than 2, negative 2. And we have here where x is greater than 0. So x now cannot be less than 0. So this would be, so x has to be greater than, so x has to be greater than 0. So now we've established that. We go ahead, and because this will help us to identify what's if a solution is extraneous. Next step is to apply the laws of log, in this case here. We can apply, if you look at this here, we can apply the product law. Just remember, in front of you your product law. Here we have a plus, so we'll use the product law. So we'll have 3 is equal to log 2. Now it's x plus 1 times x. So x plus 1 times x. Three is equal to log 2x squared plus x, that'd be x squared plus, now, oh, it's actually 2 here, plus 2x. This is familiar now. Now we will write this as an exponent. So this becomes 2 to the power 3. So 2 to the power 3 is equal to x squared plus 2x. Now, I prefer to write the x on the left side, so I'll just translate that. Now, we are going to factor this guy here by putting all on one side. So simplify it. We have x squared plus 2x to the power 3 going to give me 8. Oh, minus 8 equals 0. Now I factor. So we have x and x. So we have what give us 4, and this will be what, -2. Yes. Okay. So we have x is equal to 2, or x is equal to -4. Now, we've already established that x has to be greater than 0. So we have x equal 2 and x equal to -4. So x, this is going to be referred to as extraneous because it is less than 0. So because it's less than 0, so this is extraneous. So this is your final answer. X equals 2 because x equal -4 is extraneous. It is less than 0. Now we can verify this, that this is correct. So let's verify it. Here we have the right side. So we're going to rewrite my so x equals 2. So look at my right side. So my left side is 3. So we have our left side here. Right side is equal to log, it's my right side here, 2 plus log 2x. I replace x with 2. So we have a log 2 plus 2 plus log 2. So we'll have log 2 power 4 plus. Now go back. Remember we have our log definition, which is log b to the bn equals n. Use the same principle here. This is going to give me log 2 to 2 power 2 plus log 2 to power 1. So this will give me 2 plus 1. So 3. So the right side is equal to 3, which is equal to the left side, which is equal to 3 also. So this is verifying your solution. Now, if you were to go ahead and use -4, you'll find it is not valid. So let's review our steps again. We are asked to solve and verify the log. The step 1, we consider the values of x for which each log is defined. And we said that x is greater than -2 and x is greater than 0. So x has to be greater than 0 for this log to be defined. Next step, we apply the product rule to arrive at our simplified log. Following that, we write an exponent, we simplify, and then we factor. We have two solutions, x equals 2 and x equals -4. X equals -4 is extraneous solution because by definition the log has to be greater than 0. So our answer is x equals 2. We will verify our solution by substituting the value of 2 into our equation, original equation. So we solve for the right side. We found that the right side is equal to 3, which is the same as the left side, which is also 3. There are two examples. I just said example B because it has more than one steps than compared to example A. We look now at solving exponential equations. So far, we've looked at solving logarithmic. We've solved two types of logarithmic equations. Now, we looked at solving exponential equations. So we have 3. We have 12 is equal to 4 to the power x. And we have b is equal to 3, or bracket 2 to the power x plus 1, and c 3x plus 1 equals 6x. Let's look at the first one. So we're going to solve each one. So we have a, for the first one here, we have so 12 equals 4 to the power x. The first step is you would like to take the log of base 4. And now this gives you a good indication here. Okay, step 1. So we have take log base 4 of each side. We're doing this because we will then be able to find for x. That is because we're going to have log b to the bn is equal to n. We'll be applying log definitions. We have here now, we have log for 12 is equal to log for 4x. Know this, right? Now this entire side now becomes x. So we have is equal to x, and on the left side we're left with log over 12. I'll just rewrite this the other way around. For now we are going to use the change of base formula. So x is equal to log 12 over log 4. And so now this becomes a log base 10. This is what we'll need our calculator. And I'll have log 12 divided by log 4. Is approximately 1.79. So we have x is approximately 1.79. So step 1, take the log base 4 of each side. Then we lose the definition for log. Next step, we apply the change of base formula to give us log base 10. And then we use our calculator to find the value of x. Let's move on to B. So here we have 36 to 3, 2. We want to simplify first, and we look for common factors. And we notice that 3 is a common factor here. So we divide both sides by 3. So divide so we have what 36 over 3 is equal to this give us 12. So we have 12 right here. 12 is equal to x plus 1. Okay. Remember the first one we did here, we took the base 4. If you look where the x is. Now, if you look at this here, we have 2 to the power x plus 1. So we'll take the log of base 2 in this case. So let's move on. I'll just rewrite it here. I'll just make it x plus 1 is equal to 12. So take the log base 2 of each side. So I have here log 2 x plus 1 equals log 2 12. You're left with x plus 1 is equal to log 12. Take this here. We have we simplify for x. We solve for x. So it'll give us x is equal to log 12 minus 1. Next, we can apply the change of base formula. That will give us x is equal to log 12 over log 2 minus 1. So log 12 over log 2, we'll go to our calculator here. So log 12 divided by log 2 equals 3.58. So x is equal to 3.58 minus 1. So x 2.58. So that's my final answer. Oh, by the way, that's an approximation. I'm going to put my approximation symbol there. Okay, we have a final one. Okay, let's try this all here. Which is, so for C, that is 3x plus 3 to the x plus 1 equals 6x. Follow the same process as we did earlier. We will take the log. In this case, we'll take a common log because notice these are all to the power unknown exponent. So in this case there, we take the common log of each side. So take the common log of each side. In the previous one, we used a different base because that was 2 here. Here we can use a common log. So take the common log of each side. So we'll have here log 3 x plus 1 equal log 6x. Remember, this is base 10. These are all base 10. We'll apply the bracket around here. Brackets here. So we'll apply the power law in this case here. So I'll take this over here. So apply the power law. And put x plus 1 log 3 is equal to the power law here, x log 6. We apply the product law. We have x log 3 plus log 3, 1 times is equal to x log 6. This is applying the distributive law here. Next, we collect like terms. So we collect like terms, so we can put that here. So become x, we combine the x's together. So we have what? X log 3. I'll put it on the right side here. Put the x's together. So we have log 3 is equal to x log 6. I'll take this to the right side, become negative x log 3. Now we can simplify this, become x log 6 minus log 3, log 3. This is quotient law, so we have x becomes log 6 over 3. Log 3 just log 2. So now we have, it altogether becomes log 3 over log 2. So this is 2, we get into 2. So log 2 over log 3 will give me, in my calculator, okay, what will that give me? Log 3 divided by log 2, 1.58. So x equals 1, approximately 1.58. So the final question, first of all, we take the common log of each side because we have to the power x. Then we use our power law to simplify. Next, we collect like terms and remove x as a common factor here. So x is common factor for both of these. We apply the quotient law, simplify, and then solve for x. In this case, we didn't have to apply the change of base because we are at the beginning took the common log, which is base 10 already. Okay, so today we looked at 2 examples, questions of solving a logarithmic equations. 1, 2, and then we looked at solutions of exponential equations, solving them algebraically. The next lesson, we'll look at a few other examples from your textbook, and some that are more extensive than the ones we just covered. Your assignment will be to complete lesson 7 in your example booklet. There are 2 pages, so complete both of them.